Good afternoon, everyone. It's great to see such a large group here today, and very appropriate for our Warren K. Lewis Lecture. It's my pleasure to welcome you to the 2017 Warren K. Lewis Lecture in Chemical Engineering. Before I introduce our honored lecturer this afternoon, I'd like to say a few words about who Warren K. Lewis is. Doc Lewis, as he was affectionately known by his students and his associates, had an enormous impact on shaping this chemical engineering program and the field of chemical engineering as a whole. He received his PhD in physical chemistry from the University of Breslau in Germany in 1908. And then he joined MIT as an assistant professor in 1910 and was later promoted to full professor in 1914. Doc Lewis was the first head of the newly formed chemical engineering department at MIT after it fully separated from chemistry, and he served as head from 1920 to 1929. After that, he devoted himself to teaching, research, and consulting, and remained an influential member of the department until his death in 1975 at the age of 92. This is a picture of Doc Lewis teaching. He was known to be a very engaged lecturer and someone that essentially loved to pull the students in to the audience when he did his lectures. In fact, he was a superb educator. Lewis revolutionized the design of chemical engineering equipment with the concept of unit operations, the first paradigm of chemical engineering. He was an eminent researcher and inventor. He contributed much to the field of industrial chemistry, with over 80 patents to his credit. As an example, he pioneered the use of fluidized bed catalytic cracking in refining. Above all, though, he was an educator. His text, Principles of Chemical Engineering, with Walker and McAdams in 1923, was the first to truly define our discipline. His lectures are legendary for the combination of beautifully organized material and Socratic exchanges with his students, as you can see here. Not surprisingly, Doc Lewis won many awards, among them the Presidential Medal of Science, the President's Medal of Merit, and the Priestley Medal from the American Chemical Society. As a most fitting honor, our professional society, the AICHE, has honored him with the creation of the Warren K. Lewis Award, which recognizes outstanding education in chemical engineering. Now, the Warren K. Lewis Lectureship here at MIT was established in 1978 to recognize Professor Lewis's revolutionary impact on chemical engineering. By developing the concept of unit operations, first proposed by A.D. Little and William Walker, he revolutionized the design of chemical engineering processes and equipment. Throughout his career, Professor Lewis was mindful of the needs of industrial practice. Accordingly, the Lewis Lecture features speakers from industry and academia. Antonio Pietri is President and Chief Executive Officer of AspenTech and also serves on the company's board of directors. Before his appointment to President and CEO, Pietri served as Executive Vice President, Worldwide Field Operations, where he led global sales, sales operations, professional services, and customer support and training. He previously served as Senior Vice President and Managing Director, Regional Operations Asia Pacific, based in Singapore and Beijing, China. Now, as you know, this department has a special connection to AspenTech. Founded in 1981, AspenTech was born out of a joint research project between MIT and the U.S. Department of Energy in Advanced System for Process Engineering, or ASPEN project, founded by Larry Evans, a member of our chemical engineering faculty, and ASPEN's first CEO and chairman. Professor Evans and his team founded AspenTech to commercialize their solutions for process optimization. Today, these solutions are used by 1,200 process companies worldwide, including 46 of the top 50 chemical companies. Pietri joined AspenTech through the company's acquisition of SetPoint Inc. in 1996. At SetPoint, Pietri held a range of sales, services, implementation, and consulting roles, where he oversaw integration of AspenTech solutions at European refinery and process manufacturing sites. In 2002, he relocated to Singapore as Vice President, Business Consulting, and was subsequently promoted to Managing Director of the Asia Pacific region. Pietri began his career at ABB Simcon as an applications engineer focused on advanced control and multivariable controllers for refining. Pietri holds an MBA from the University of Houston and a very proud holder of the Bachelor's in Chemical Engineering from the University of Tulsa. It's with great pleasure that I introduce to you Antonio Pietri, President and CEO of Aspen Technology.
Well, first of all, thank you for such a kind introduction, Dr. Hammond. And it is my honor, actually, to be here today as the guest lecturer for the Warren Lewis Lectureship Series. As Dr. Hammond alluded, Aspen Technology has deep roots in MIT. Also, many of our employees have their degrees from MIT. Many PhDs in Aspen Technology are from MIT as well. Today, what I'd like to talk about, it's a combination of a little bit of history and how technology with the intersection of business, drive, innovation, and have driven a company like Aspen Technology, and the need for any company to continually be innovating and finding new ways to push and create value for our customers. Before I start, though, I do want to recognize certainly the contribution of Larry Evans, the founder and CEO of the company for many years. And I remember very clearly after Larry bought the company that I was in, taking a trip with him to my home country, Venezuela, to do a presentation in front of a customer and having to talk about his vision to this customer, and which was a very nerving presentation. But apparently he thought I did well because he kept me employed in the company, and today I'm the CEO of the company. At the same time, I also like to recognize Dr. Stephanopoulos because he's also made his contributions to the company in more recent years. We founded what we call the Aspen Tech Academy, which is an advisory board of well-renowned professors in chemical engineering in the industry. And Dr. Stephanopoulos was the founding professor and chairman of the academy for 4 years until he stepped down last year as well. So thank you, George, as well for that contribution. So I'll get started today and tell you a little bit about Aspen Technology. I'm going to be talking about some technologies and innovation that is not out in the market, and this is what technology companies have to do today to be safe in the marketplace as far as complying with regulations. I don't think I would do the honor to talk about the history of Aspen Tech myself without actually letting Larry himself talk about the beginnings of the Aspen project, what was accomplished with that project, and then a little bit of the history of the company. So I'd like to invite Larry to actually spend 5 minutes talking about Aspen Technology. So Larry.
Well, thank you, Antonio. I was very surprised when Antonio asked me to make these comments. I met with him this morning, and so I prepared a few notes just to keep me on time. I came to MIT in 1962 as a new assistant professor from Michigan, and I was very interested in computing. This was the era of mainframe computing, where you provided your input to the computer on punch cards, you took it to the computer center, you got the printed results back the next day. But by the 1970s, MIT had become a hotbed of activity in computer-aided problem solving. There were large research projects on computer-aided mechanical engineering, computer-aided electrical engineering, civil engineering, and I asked, why not chemical engineering? At the time, every major oil and chemical company had their own proprietary modeling system, but these were very primitive. And my vision was to create a next generation of computer modeling system that took advantage of new computing technology and would be much more powerful. But that would cost a lot of money. And in 1975, when the first energy crisis came along, I saw the opportunity. The supply of oil from the Middle East had been cut off. There were long lines at all the service stations for people waiting to get gas, and it was eventually had a form of rationing. And the U.S. wanted to become more energy independent, and we thought we were going to have to build hundreds of so-called synthetic fuel plants to make fuels from coal. And I knew to design and build those plants, we were going to need much better tools. The U.S. Department of Energy was formed. And at MIT, we created an interdisciplinary energy lab, which was the predecessor of today's energy initiative. So I went to the Department of Energy with a proposal. The goal was to create a common software system called ASPEN, which stands for Advanced System for Process Engineering, that everyone could use and would become a standard. DOE funded the project over 5 years at $6 million, which was a lot of money at that time. We recruited experienced people from industry to come work at the Energy Lab on loan from their companies. And we built out space in Building 20. And there's the old Building 20 there in that slide. That's where the Stater building is today. And we formed an advisory committee of more than 50 companies. And in 1981, we finished the project, delivered the software to the Department of Energy, and anyone could get it free from the government just for the cost of reproducing a computer tape. But we knew that the software wouldn't be used unless it was supported and continually improved. So I founded AspenTech along with a number of co-founders from AspenTech, and many of the founding employees are here today, sitting in the back here. I took a leave of absence from MIT to serve as CEO. We rented space from MIT in a one-story building that was located where the Simmons dormitory is today. And when my leave from MIT ran out, I gave up my tenured position to become full-time at AspenTech. And we created Aspen Plus as the company's primary product. But at the time, we were competing with something you could get free from the government. But companies licensed our software because they knew it would be continually improved and supported. And the company was a success. It grew steadily. We attracted venture capital finally in 1986, and we went public in 1994. We had a vision to go beyond Aspen Plus on the engineer's desktop to be able to use the same models that you use to design the plant also to run the plant and to control the plant. And over the next 8 years, we acquired more than 20 companies. And in 1996, we acquired SetPoint and DMC. These were two arch competitors located a few miles apart in Houston. Neither company knew we were talking to the other one. And so in one day on, I think it was January 1996, we made, what?
January 6th.
That's all I was going to say, January 6th. We knew, we finally made the announcement. And when we made the announcement, it was a complete surprise. It was like a shotgun wedding putting these two arch competitors together. And it more than doubled the size of AspenTech. And it also electrified the industry. It made the statement that AspenTech was going to be more than a desktop modeling company. Our stock price doubled, and that's how I met Antonio, who had been working at SetPoint. And I stepped down as CEO in 2002, having served as CEO for 21 years, and my successors have done a wonderful job. The rest of the story is what Antonio's going to talk about, but you have one or two slides.
I have one more slide.
And this is in front of the building on Vassar Street, I believe, where we were renting space from MIT. And the building now has come down, and the Simmons dormitory is there instead.
I'd like some of the employees of AspenTech that are on this picture to please stand up. Come on, Bill, Willie. So, yeah. Great. Thank you very much, Larry. Really appreciate that. All right, so that was the beginning. That was 34, 35 years ago. And as you can see, we all looked a lot younger back then. And a lot has happened in this journey. So today, Aspen Technology is a global leader in asset optimization solutions for the process industries. That really is engineering and construction, chemicals, oil and gas. We're the #1 company. 90% of our revenues come from these companies. We're about a $500 million revenue company, about 1,400 employees around the world, offices in 29 countries, and one of the most profitable publicly traded software companies in the United States today when you talk about operating margin and cash flow generation. And this is the outcome of an idea in MIT, and 35 years later, what we've turned it. The market capitalization of AspenTech today is $4.5 billion, and that's the result of a lot of hard work by a lot of people in the company. So let me just give you why AspenTech. And the fact is that our solutions create tremendous value for our customers. Unlike a lot of other software companies where it's hard to quantify the productivity or the value that is created from the use of our technology, every one of our customers can put a dollar number to the improvements or both the operational improvements or productivity improvements that our software delivers for them. And these are some of the examples. If you can see from the use of our engineering design software, Chevron Corporation, $30 million in CapEx savings from the use of our technology. There's examples of savings from the use of advanced process control and many of the solutions that we have today. The fact is that we're a highly concentrated company into 3 industries. 350 customers generate 80% of our revenue. But those are the most global companies in the world. If you think about the ExxonMobils of the world, the BASFs, the DuPonts, the Bayers, the Fluors, the Technips. So it's 350 companies, hundreds of thousands of users, and thousands of assets around the world. If you roll up the value, we estimate that through the installed base of technology that we have today in the market, our customers generate on an annual basis about $50 billion in value, in profitability for them, and that it's every year. So let's talk a little bit about why Aspen Technology and technology trends, because the fact is that what you see today in the market is about technology trends. This is from a white paper that the McKinsey Global Institute published in January of this year, where they talk about the impact of technology trends on productivity and productivity's contribution to growth in the global economy. If you look at this trend, you go back to 1850 with the steam engine, and they estimate that the steam engine between 1850 and 1910 contributed about 0.3% of growth to the global economy every year as a result of the invention of the steam engine. Similarly, with early robotics in between 1993 and 2007, about 0.4% productivity or contribution of growth through productivity to the economy. And really, that's the phase of the automation of the manufacturing line around the world, and the dislocation that it created around jobs, but eventually all those jobs moving up to higher skilled positions. Then IT, more recently between 1995 and 2005, the contribution of IT to growth in the global economy. Now, one of the big questions that exists today after the financial crisis in 2008 and 2009 is the fact that the contribution of growth the contribution by productivity through growth has diminished, and the question in the United States is whether the United States can continue to grow or get back to growing at 2.5%, 3.5% rates of growth when this productivity contribution has disappeared now. Now, AspenTech really started developing in the mid-90s, and in a way, we were part of that IT productivity growth contribution. But the fact is that in the process industries, what we did for them was always consider automation. Automation through advanced solutions, which really, I mentioned that because it informs the next point here. McKinsey estimates that the next big trend in technology that will drive growth through productivity is what they call automation. But what they really refer to as automation is robotics, artificial intelligence, and machine learning. Now, the range of productivity depends on when the adoption of these technologies happen. If they happen in the if they start happening between now and the next 15, 20 years, the contribution to productivity in that period will be 1.4%. If that adoption happens later in the period, then it will drop somewhere between 0.8 and 1.4%. And this is important to understand because this is what we're seeing today. Every company out there is talking about analytics and what they're doing with analytics. There's a lot of talk about robotics. Japan as a country is making a big investment and a big bet on robotics as what they're going to use to drive their economy going forward, and also machine learning. Now, in this context, I like to say, because with machine learning and analytics, there's the talk of the industrial Internet of Things. What I would argue is that the industrial Internet of Things happened in the process industries 30 years ago, because the process industries went from analog to digital technology for control of their systems or their processes, starting in the early 80s through the 90s. These are processes that are very difficult to control. They are dangerous processes, and therefore they required a lot of measurements in order to manage them. The thing about that transition in the process industries in the last 20, 30 years is that it generated tremendous amounts of data, but very little was done with that data. That data has been stored, and there's reams of data out there that was never really leveraged for greater value. What's really happening now is that with the advent of some of these technologies, we're starting to exploit all that data that's being generated out of these process plants, and we're going to be able to do analytics on them. And I give you this context because it is important to understand the direction that AspenTech is taking going forward. So if you think, at the same time as those technology trends were having our impact, I would categorize the phases of growth of the company as, of course, the project in MIT. Then the company goes public in 1981 and becomes a process modeling and simulation company. If you're a chemical engineering student, you have used Aspen Plus, or you will use Aspen Plus as you get to be a junior or senior in MIT. But as Larry said, in 1994, Larry started a pretty aggressive acquisition phase for the company. And between 1994 and 2002, Aspen Technology acquired 23 companies and consolidated the advanced solution space in the process industries. SetPoint was the second or third company, depending on, Larry, which agreement did you sign first? SetPoints or DMC Corps? Doesn't matter. Nonetheless, after that second and third company, there were 19, 20 more. But that really moved the company from a modeling and simulation company to a process optimization company. And that's what we've been up until about 2 years ago. I became the CEO of the company 3.5 years ago. And as the new CEO, I started to think about, well, what are the areas that, based on what we have created here, we can move into to create more value for our customers and more value for our investors. And that really kicked off our strategy, and I'll talk about that in a minute. But the outcome of the last 35 years is two very powerful suites of technology. Our engineering design suite, which basically has the deepest and broadest set of functionality for the design and engineering estimation for the process industries. Aspen Plus being used for conceptualization and basic engineering design, but you can do cost estimation, you can do detailed engineering for heat exchangers, you can do energy analysis or pinch analysis, you can do a broad set of tasks with this suite, and basically it's the standard in the global industries today. And then the second suite is a suite that was the outcome of 23 acquisitions, and is our manufacturing and supply chain suite, where we can plan a refinery and what type of crude oils that refiner is going to use, or what type of feedstock a chemical plant is going to use to produce the plastics that have to be produced, through to the scheduling, the advanced process control, the optimization, the real-time data management, blending, and so on and so forth. About 40 products on the engineering suite, about 60 products on our manufacturing and supply chain suite, and that's what we've been driving to market over the last 35 years. Now, going forward, how do we plan to drive value for the industries that we serve, and investors, and for AspenTech? And really, that is what we have launched 2 years ago, and is our asset optimization strategy. Is the evolution of the company from a modeling and simulation company to an asset optimization company. And as you can see, these phases have lasted anywhere from 10 to 15 years, depending on what was going on with the company. Now, it's always about continuing to maximize the return on the asset, and it's about, with these technology trends, it's about continuing to get more return on the capital employed on the assets that are already built and on the ground, and this is what the industry is looking for. Building a refinery today is a $5 billion proposition. A chemical plant, depending on its size, can be anywhere from a few $100 million to $5–10 billion. The largest greenfield grassroots petrochemical complex built in the world in one go, all at the same time, is the Sadara petrochemical complex in Saudi Arabia, a $20 billion investment. So if you're going to invest $20 billion in building something, you want to make sure you get the maximum return on that investment, and this is what technology does for these companies. So as the CEO of the company, if you're going to drive a strategy, you want to give some guiding post or some principles to the organization to execute on that strategy. And the principles that I defined for Aspen Technology after I became CEO are one of innovation, focusing on the customer to enable their success. And enabling success for our customers is about creating value for them and for Aspen Technology as well. And it's about market leadership. And unlike perhaps in a lot of places in Aspen Technology, market leadership is not about putting a banner on the wall that says we're number one. Market leadership in AspenTech is about the responsibility that we feel to serve the industries that where our customers reside, to advance the industries that we serve. And that's very important, and that's really the outcome of the passion that exists in AspenTech, starting with our roots here in MIT. So the asset optimization strategy is really, we define it as a comprehensive, holistic approach to driving the highest possible financial return over the entire asset life cycle. So our engineering design suite is for the design of the asset. Our manufacturer and supply chain suite is about optimizing operations. We believe we are uniquely positioned to extend ourselves to the maintenance of those assets in order to be involved in the full asset life cycle of these plants. And again, is to maximize the asset in totality. And what that really means for Aspen Technology is extending ourselves from what's being processed to what's being processed and the equipment. Not only do we want to understand how do we fractionate the crude oil into its different components, but we want to understand how the process conditions that we're operating that equipment at are degrading the performance of that equipment or are impacting the performance of that equipment, because this gets to the reliability of those assets. We also want to extend ourselves from being very focused on the unit or a piece of equipment or the process unit to the plant, the site, to the system, so that when we think of reliability, we're thinking about the reliability of the system as a whole, the reliability of all the assets in an envelope that you have to take into account in order to meet your customer requirements. So it's about extending ourselves outside of the process unit. And then lastly, extending ourselves in the life cycle from design, operate, into maintain. And the way we represent that these days is through our asset optimization strategy. What we want to do is not only deliver solutions in the maintain space, and I'll talk about what type of solutions those are going to be going forward, but we want to be able to leverage, we want to be able to say, if we're going to design this asset, what are the trade-offs that we have to make between operating that asset at certain conditions and the impact that those operating conditions will have on equipment and the reliability of the equipment, so that we make trade-offs between OPEX spend, operating expenses spend, versus capital expenses spend, and optimize the cost that is involved to build that asset, taking into account the sort of availability and lifespan of the asset. We want to understand how the design of an asset impacts the operating of that asset, and all the permutations that you can have in this full life cycle. So, sometimes when you're in business, it is talking to your customers that the ideas, that crystallizes your ideas, or it is talking to your customers that you get some of the best ideas for your products. And this was a conversation that I had with the head of a chemicals company in Europe, where if you read what it says, this customer was basically saying, Antonio, I don't need any more of your optimization technology. My ethylene crackers, my polymer plants are fully optimized. Thank you. Of course, as the CEO of Aspen Technology, that's not what I want to hear. And in a way, I know that there's more opportunity. But his point of view after some exchanges was really punctuated by the following statement. We need to improve the reliability of our assets, because you can optimize any system to the nth degree, but if that system breaks down, all that is thrown away. And the important message was, we've done everything we can, according to him, to optimize my operations, but my equipment, my asset is breaking down. I'm having to shut production. And doesn't matter what optimization technology you're selling to me, if my asset is not operating, I'm out of business. So the point was, it's about reliability. The biggest value, the biggest bucket of value that now it's available to us is improving the reliability of our assets. And that was an important point, because it really crystallized for me that from a standpoint of our asset optimization strategy, we were onto something in the market. So the customer was right, though, because this is a study that ARC, a consulting company involved in the process industry, did in 2015 around proactive asset management and IoT, where they determined that despite all the preventive maintenance that these companies are doing on their assets, they're only addressing 18% of the failures. 82% of the failures are unexpected, unplanned, and they didn't do anything about it. So the point is that the bigger value in all of this is, how do you address these 82% of the failures that are unplanned and unpredictable at the moment? That's where the real value is, because the billions of dollars that are being spent on preventive maintenance are only addressing 18% of potential failures. Think about it. You go through winter, spring shows up, it's going to start to get warm. You call the maintenance guy for the air conditioning unit. Come in and do some maintenance in my air conditioning. They do. The cables were not eaten by the mice, so you're good. They leave, and in the middle of the summer, your air conditioning breaks down. But when you call that person is too busy because there's another 100 houses with the air conditioning out of service, and you spend a few hours in your house sweating. Similarly, filling. They're spending billions of dollars in preventive maintenance on these assets, and it's not addressing the problems that are going to show up. And that is the big opportunity. So what we tell our customers is that AspenTech is going to focus on the maintenance space, but we're not going to focus on the preventive maintenance. There's already companies trying to do that, and the fact is that they're not delivering a lot of value for our customers. We're going to focus on the science of maintenance. We're going to focus on the engineering, the analytics, the technology, the deep know-how that is required to solve the 82% problem that our customers have. So the thing is that 82% problem is about reliability, because the equipment is breaking down, the equipment is degrading, and executive reliability is an executive level responsibility. Because reliability in the process industries is not necessarily about an equipment breaking down. Reliability in the process industries is about an explosion happening that could kill people, that could damage the environment, that could have an impact on the communities where that plant is, and eventually is about the brand, the reputation, and the profitability of that company that is running that asset. So reliability is not necessarily about equipment. It's about the potential consequences of a chemical plant having a disastrous accident that could cost lives and impact to the environment and the communities, and eventually the reputation of that company. And we've seen some of those in the last few years, as you well know. So if it is an executive responsibility, well, what is it? What's at stake is about maximizing return on that asset. But as I said, that maximizing return on that asset is much more than profitability. It's people, environment, community, brand, reputation. So what can you do to mitigate what's impacting that reliability and the return on that asset? And there are hundreds, thousands of things that happen every day that impact reliability. What that customer was really saying, from an operational standpoint, we're satisfied with the reliability of our plant. We've optimized it. We're getting what we want out of our plant. We're not satisfied with the mechanical reliability of our asset. Two different types of reliability problems that get combined into one, but you have operational reliability. Are you operating your assets in a way that is safe, that is actually maximizing your return on investment? But from a mechanical standpoint, are you achieving the same thing? And if you're not, then that's what you're going to worry about. So that's what these executives worry about, and therefore, from AspenTech's standpoint, asset optimization is really about improving the overall reliability of these refineries, chemical plants, and any type of plant. And I just want to say that while 90% of our revenue are in these three industries, our products are used in all sorts of industries. I'm sure a lot of you like to drink beer once in a while. Guinness breweries around the world use some of our technology. Tyson Foods uses some of our scheduling technology in their chicken deboning processes. Our technologies also use baggage handling systems. So they're very horizontal in nature, but as a company, we're narrowly focused, because focus is what drives execution inside companies. But it's about optimizing reliability on all aspects, from the design, operation, and maintenance of those plants. So what are we doing about it? Well, this is a portfolio that we've been leveraging the last 35 years to address reliability and optimization. What's our plan going forward? Now, before I talk about that, we continue to develop those two suites, and this is in Aspen Plus, and I specifically chose Aspen Plus since I know some of you are going to end up using it. So Aspen Plus has been a steady-state simulator for continuous processes. In our next release, we're going to introduce batch modeling capabilities in Aspen Plus, where you can not only simulate a continuous process, but you're going to be able to simulate the batch part of a process and the continuous part of a process all together and run a simulation in the same flow sheet. No other simulator out there does this today. and you're going to be able to do that soon in Aspen Plus. In addition, you're going to be able to model crystallization processes. You're going to be able to model particle sizes in those crystallization processes and all sorts of interesting things. And this is one of the advances we're including in our Aspen Plus technology going forward. The other piece, which I talked to the faculty at lunchtime today, this is a refinery planning solution. So Aspen Technology has 75% market share in refinery planning around the world. 75% of the refineries around the world use our planning solution to plan their operations. And you would ask, well, what's our incentive to actually do anything to that product if we already have 75%? The real reason is, one, there's always competition. Two, there's a new generation of users that is coming into industry, which is you guys, a lot of you here in the industry, that have a different expectation about what software should really be. The user experience, the touch and feel, how you move around the software. So our PIMS product, which was the first desktop-based planning solution created in the late 70s, early 80s, is old. It's about 35 years old as well, 40 years old. And it fell to some of our customers that way, and we started to get feedback about the fact that the competition was coming out with a lot more user-friendly technology for planning. Perhaps not better functionality, not better optimization algorithms, not better functionality in general, but it just felt better to use it. It felt better to configure it. So there's a big investment that is going from our part into our products to improve the ease of use of the products that are now standard in the industry, but that some users are now starting to feel they need to be improved from a usability standpoint. And this is coming out soon as well. So our Asset Performance Management Suite is the outcome of a simple decision. As CEO of a company, and Willie Chan, our head of technology, when we think about innovation, we think about innovation in two ways. We can either build this, and if we're going to build it, how much it's going to cost us and how long it's going to take to build it, or we can go buy it. And buy it really means what company are we going to go acquire. This suite is the outcome of both build and buy. The fact is that the Fidelis Group is one of the leading companies in reliability analysis for refining and chemicals and really any type of capital-intensive asset. And we bought this company last June, and with it brought significant capabilities around asset reliability. When you're looking to make trade-offs between what is the size of your process units, what should be the size of your tanks, what is the availability you want to have in that asset, and therefore what is the redundancy of your equipment, what is the type of equipment you need to put in place. Those are all trade-offs that you make based on the availability that you want to have for this equipment and the production that you want to achieve. The next box there, MTEL, equally machine learning technology. And this company was working on machine learning since 2006. They had established successful references in the industry by using machine learning to be able to predict when equipment was going to break down. And we decided, instead of spending 10, 11 years developing our own machine learning technology, we went and bought this company last October. ProMV, a little bit of a different story. We didn't buy the company, but we bought the technology assets of the company. So we extracted the technology from the company and we left the technology in place. They want to be a services organization, but now we have the technology, and it's multivariate analysis, statistical analysis that you can use to discern the variables that are influencing an outcome. And then the last box there is Aspen Asset Analytics. Now, this was a decision to build. And that decision was really about two and a half years ago, and really the genesis of our strategy around asset optimization. After 35 years, we had become somewhat of a platform for our customers because they used a lot of our products to drive their assets. Our engineering design tools were used to do the design of those assets, and therefore a ton of models out there that reflected these assets. Our products were capturing all this data that is coming from these assets, and our products were also used to generate information that's being used to run these assets, to make decisions on how they're going to operate. So if that's the position that you have in the marketplace, then how can you leverage that position? How can you leverage all those engineering models? How can you leverage all that data, all that information that is in your products, and you're the only one that knows how to get access to it, how to use engineering models with the data, with information to create more value for our customers. And that's where the idea of an analytics solution came about, where we are now with Aspen Asset Analytics, we're combining first principle engineering models from Aspen Plus. We're combining data analytics, search and pattern recognition with empirical data models, and we're bringing all that together into a solution that is targeted at detecting when a distillation tower is going into flooding stage. So flooding, if you're an operator in a plant, is one of the common problems that happens in that the fractionation capacity of the trays inside those towers are overcome by the amount of liquid, and there's not enough flow in the process. And it takes hours and sometimes days to get one of these columns back into normal operating conditions. And during that time, basically you're producing off-spec product, and that costs a lot of money. It goes back to operational reliability. So the ability to predict when a distillation or fractionation tower is going into flooding represents a lot of money. Now, the requirement that I gave our R&D team was, if we're going to create a solution that is bringing together all these products, it has to be snap-on analytics. It cannot be $1 million project to implement it because we're not going to get traction in the market. It has to be something that, while it deals with all the complexity and all the technology that I talked about, is easy to implement. And we have achieved that, and customers are already testing the product, and it's capturing value. So, and really this suite will be targeted at maximizing uptime with actionable insights for our customers. So the insights is really looking through the data, looking through all that information and saying, here's the additional value that you can capture from all this data. So our set of analytics range across many areas, sort of from risk analysis, which is reliability analysis, to root cause analysis, pattern recognition, and the assembling of model and data for our Aspen Asset Analytics, multivariate process analysis, and machine learning, and so on. This is all important because this is a whole new area in the process industries. And the conversations that we're having today at lunchtime, until 2 years ago, there wasn't a single data scientist in Aspen Tech. Most of us were chemical engineers with deep domain expertise on the process industries. We understood how these plants operate, but we had no data scientists. We started to hire a group of data scientists, and today we have a team that approximates 10 to 12 of them that bring with them the expertise on data analysis, that when you pair with the domain expertise of chemical engineering, magic happens around what value can be created for these customers. And the point I want to make there is that there's out there in the world, there's talk of analytics, and of course there's social media analytics and other type of analytics, but analytics as applied to the process industries will become very important. And we had our global conference last week in Houston, and our customers were very happy that we're going in this direction. Their feedback to us was, the problem that we are having is that we're not able to attract data scientists to our companies, which in my opinion, creates an opportunity for chemical engineers. If you go back 20 or 30 years, as Larry got focused on computer-aided solutions, programming became a skill that was required of chemical engineers. And the fact is, for the better part of our last 35 years, it's chemical engineers that have been doing the programming in Aspen Tech. Going forward, I believe that it will not only be computer programming, but also there will be a requirement for some data science skills in chemical engineering graduates as part of your day-to-day jobs. And that's, in my opinion, how the industry will address the issue of attracting data scientists. Because what's important, and I'll make the comment before I talk about this, the important thing about analytics and data analysis is not just doing data analysis for the sake of it. You have to have context to the data. You have to be able to understand what the data is telling you. If you don't know anything about chemical engineering, if you don't know anything about operating a chemical plant or a refinery, then you're going to be looking at that data and what that data is going to be telling you, but you're not going to know what to do with it, what you're going to prescribe to operators and engineers. And that's what then the domain expertise gives you, the chemical engineering training, the process experience. So when you hear companies out there talking about analytics, you may want to ask them about what expertise they have in the industries that they're trying to sell those analytics to, because that's the context that's required to create value out of data. So our performance analytics, which is really machine learning, is about pattern search discovery, and it's about detecting failures. Now, AspenTech has real-time data management systems, and we've been collecting data from these plants for decades. So we get 1 minute data every day for years and years, and as you can tell, that is a lot of data. Now, what do you do with this data? Well, with machine learning, what we're trying to do is discern through all that data and identify patterns in that data that were precursors to a breakdown in equipment. Whether it's a pump, a compressor, a turbine, any sort of rotating equipment. Now, there are other industries that don't necessarily have rotating equipment. They could have dryers that are static equipment that they also break down. You can also apply machine learning to those type of equipment. But in this case, what we try to do is look through that data with machine learning and identify patterns in the data that were associated with a breakdown, and the technology automatically creates agents, which is basically a fingerprint of that data pattern that is then used going forward to monitor the process. And as you can see, if you go back through days, weeks, and months of data, you will identify a lot of very unique fingerprints or patterns in the data that were precursors to a breakdown in the equipment. Now, part of what we have to do is associate maintenance logs, because we want to be able to tell, well, if this is a precursor, what happened then? And you'll find that in the maintenance logs of these plants, where an operator had to manually write that the equipment broke down, or is automatically captured in enterprise asset management systems where all the maintenance records are kept. But once you run all your data through machine learning technology, you generate all these agents. You may also generate agents that detect abnormal conditions that are not necessarily precursors to a breakdown, but nonetheless, you generate agents. Now, I'll give you an example later, but one of the railroad companies in the United States, CSX, is using machine learning to identify when their locomotives are going to break down. They have they're in the process of deploying 100,000 agents through our older locomotives to monitor the performance of those locomotives. And they so believe in the technology that the minute one of the agents signals that the locomotive is going to break down, they take it out of service. And I'll tell you about the value proposition on why that is the case. But once you have created all these agents out of the historical data, then what you want to do is monitor the process real time, so that as the fingerprints, as the patterns in the data develop, then the agents highlight that they've identified a similar pattern associated with a breakdown, and they issue an alert. And this is then what this does for you going forward, in that then is real-time monitoring and prescriptive. As the data is coming in from the process, it identifies a pattern, and then it issues an alert, and that alert could be, go take a look at this, because it could potentially be a problem, or it issues a maintenance order which is go do some maintenance on this equipment. You can write the rules that you want the technology to act upon once you've identified the agents. Equally, the technology could detect that there's also an abnormal condition, an issue, an order to have an engineer go investigate that abnormal condition to see if it's going to lead to anything worse. So this is what machine learning is doing today, not only in the process industries, but other industries, and it's about sifting through massive amounts of data, giving context to that data and those fingerprints, and then the capability to act on it immediately. This is on machine learning. If we go to root cause analysis, well, you would ask, well, what's the difference between machine learning and root cause analysis? Machine learning is specific to equipment, rotating equipment or static equipment. Root cause analysis, similar concepts, but applied to process equipment, the equipment that is actually processing the crude oil or the feedstocks in your chemical plants. But similarly, with root cause analysis, what you're looking to identify is the event that took place and maybe some issues with a reactor. And at that moment, you identify that as the target event in your root cause analysis solution. But then you go back in history and you're trying to identify the precursors that led to that event. And it could, and not only the timing of those precursors, but the sequencing of those precursors. And you go back as far back as you can to identify all the possible precursors on that supported or were part of the root cause of that event. And I'll let this go through. So once you've identified your dependency graph and you believe you have captured enough of the precursors that lead to an event, then similarly, then you can use this online 24/7 to monitor your process conditions, looking for the same patterns in the data, the same fingerprints, to be able to act on it and keep a reactor from having an issue. So this is what this is going to show here now. And similarly, as you're feeding real-time data from the process through your systems, then you're able to match that a precursor to an issue in your reactor just took place, and therefore, what are the actions that you're gonna take about either issuing orders to an operator or an engineer investigating the situation. What root cause analysis also gives you is a probability that based on that precursor that something's going to happen, but also tells you how far into the future that the actual event will happen once you've identified the issue. So it actually gives you the time that you have to go and proactively take care of that issue. And then lastly, our Aspen Asset Analytics solution is about an ensemble of models, first principle engineering models from Aspen Plus, empirical models using a lot of the data, and again, through search and pattern recognition, establishing some data models, and then looking at the hydraulics, the column hydraulics of a tower to understand the separation in the different stages of that tower, and looking then in the data to see at what point conditions in the tower are going to lead to flooding in that tower, and we're able to visualize for the engineer or operator how close to the flooding envelope is that tower as the data is coming in. That then also gives a sense to the operator of what actions they need to take, either prescribed actions or actions based on experience that the operator have to take. This isn't available in the market. This is leading technology. All of this is leading technology out there, and really relies not only on the different analytics technologies, but the combination of chemical engineering know-how, chemical engineering principles, engineering models to bring together a solution with a lot of context for our customers. And that's the message that I want to also leave you with. But this is being tested, and we've already been able to detect in these distillation towers situations of flooding in some cases. So you would ask, this is the intersection of business with technology. You would ask, well, why target distillation columns first? Well, the fact is that when we did market research, distillation columns are the most common equipment in process plants. There's about 100,000 distillation columns around the world in different plants, and in the United States alone, there's 30,000 of them. So when we think about value creation for AspenTech, we want to target the market with the most potential, and in this case was distillation columns. But similarly, reactors, the ability to be able to predict when we're going to have issues with reactors, the ability to predict fouling in heat exchangers, and many other process conditions in these plants. So it doesn't happen just through pure technology. The fact of the matter is that in order to pull together these analytic solutions, it takes a combination of technologies and skills. First of all, if you're looking purely at process data, you're probably dealing with real-time data, but if you're looking at maintenance data, a lot of that data will probably be in papers, operator logs that are written, or it could be on other types of systems. But what you're dealing with is a lot of unstructured data. Some of it might be structured, but a lot of it is unstructured. So what is the conditioning that you have to do in this data, the aggregation, the conditioning, and then the consolidation, so that you can then feed that data through your systems. Eventually, you have to give it the insights, apply the optimization engines, the workflows, the rules, so that then you can create the prescription, the messages, the actions. And while it is easy to put this on one page and give it nice pictures and words, this takes a lot of brain power and know-how to make it happen. Similarly, then, the enabling technologies is a lot of what you, next generation, are talking about, which is very advanced capabilities in database, database management, database processing, Hadoop, data lakes, and how to get to those data lakes in a way that you can prescribe, you can detect a problem and you prescribe an action, but in a timeline that is still reasonable. Because if you detect a problem and it takes you 4 days to solve through that problem probably will already have an impact on the process. So what you want to do is use heavy computing capability, and a lot of that today is available on the cloud. You want to use databases that are able to handle billions or trillions of data points over periods to sift through that data, and all that capacity today is on the cloud, and all the different components. I won't go into any of this detail. If you want to get into this detail, the people that you want to talk to is back there all smiling about it. So why do all this? We only do this for value. And the example that I talked about, this transportation company, this locomotive company, CSX, they awarded to MTEL their 2016 Supplier Innovation Award for saving the company millions of dollars. And the fact is that millions of dollars is a 9-figure number. Every one of these locomotives breaking down on a railroad track is probably about $1 million penalty because they block the track. Normally, these railroads are pulling about a mile long of rail cars, and if a locomotive breaks down, then you have to move the locomotive out of the rail tracks. You have to bring a new locomotive, and if there's other trains behind, then they're facing delays, and that normally costs about $1 million. So today, CSX, the minute they get an alert from our machine learning technology that a locomotive is going to break down, they take that locomotive off service and bring a new one in, and that is saving them millions of dollars in operating costs. On the other side, what you have is our reliability analysis software, and this was applied to one of the largest grassroots petrochemical complexes built in the world, where this customer had a highly integrated set of process plants, 26 different process plants, starting with ethylene crackers, polymer plants, specialty chemicals. And what they wanted to understand was their ability to hit the production, the production volumes that they committed to their bankers. Again, the people loaning the money to this company to build this $20 billion project wanted to be certain that if they loaned $20 billion to build this asset, that they were going to be able to hit the production volumes that they committed to, because that production volume turns into sales, turns into revenue. And they did an analysis looking at the sizing of all the plants, looking at the intermediate storage tanks, looking at the integration between the different assets. And in that analysis, they were able to determine that they could get rid of an entire process train from one of these plants, and it saved them $250 million in capital expenditures. So this is big money. This is intersection of technology, expertise, and business to create value for customers. Today, AspenTech is now going to market with a third suite, our Asset Performance Management Suite, which is all about analytics and reliability. One of the things that we're putting into our products more and more, considering that there's a lot of expertise retiring and a new generation of people coming in with a lot of experiences, we're putting the expert into our products to simplify their use. So we're taking functionality and we're automating that functionality, we're coding that functionality so that you no longer have to know how to use those, you no longer have to have the knowledge to use that functionality in the product. Is done automatically, and really with the purpose of democratizing usage and value creation going forward. And this is how we're trying to target the knowledge and expertise that is required to use some of these sophisticated solutions. A lot of the technologies is leveraging some of these technologies that you see here: high performance computing, 3D visualization, the cloud connectivity. A lot of this is going into technology today. And more so, it's a requirement. But an important point, though, is not only about technology and processes, it's about people. And you have to have the people with the capabilities, the skills, the know-how to be able not only to implement and use this technology, but sustain the use of the technologies. And what you find today is a lot of businesses that are very keen on creating value from the use of technology, but do not have the organizational excellence, the capabilities, the skills to sustain the use of that technology. And this is where we all come into the picture. What's our role in ensuring that we're building best practices into our organizations, that we're moving up the maturity levels of expertise in these organizations to sustain the value that is being created from technology. And in AspenTech, we're looking at ways to provide organizational excellence. We're breaking down our training into more consumable pieces of learning. Video, we're converting a lot of our training to 3 to 5 minute videos so that you look at a video instead of having to read. This is how the new generation is actually consuming information, is through video, it's not through reading. So there's a lot going on in order to sustain the use of these technologies. And I'd just like to play you a video. It's a 2-minute video that I was told I needed to do something about it. There you go.
Welcome to the future of industry. Welcome to complexity. Every day, assets multiply. The data they generate increases in volume and velocity. Regulations escalate. Sources shift. Competition intensifies. Market volatility sharpens. Foreign exchange tailwinds become headwinds. And your customers still need product made well, priced right, and delivered now. The challenge of optimizing your enterprise, every plant, every system, every asset, while maintaining an impeccably safe operation has never been tougher. But what if you could put complexity on your side? What if you could embrace this dilemma and turn it to your advantage? Running assets faster, safer, longer, and greener. What if you could achieve when others fail? Persevere when others doubt. Forge ahead while others fall behind. Only Aspen Tech makes the best companies even better with technology that thrives in complexity and unleashes the full value hidden in every asset. Technology that delivers the most accurate, most actionable insights. Technology that lets you predict and eliminate failures. Technology that pays for itself in weeks or months, not years. Technology that optimizes the asset design, operation, and maintenance lifecycle in the most complex environments. Aspen Tech. Technology that loves complexity.
Great. So just to conclude, it's really about maximizing asset performance in very complex environments. It's about providing the software and insights that run those assets faster, safer, longer, and greener as well. Thank you.
Excellent. Before we open up to questions, we'd like to thank Antonio for that wonderful talk. And as you know, this is a very important lecture for us, the Warren K. Lewis Lecture. We're very proud and happy to present you with the Warren K. Lewis Lecture Award for 2017. Thank you so much.
Oh, no, thank you on behalf of Aspen Tech.
Thank you.
Thank you. Thank you.
And
Yeah.
we will open it up for questions now.
Yeah. So my final comment would be, before any question, an idea in MIT has turned into this, so the world is your oyster. Questions? Yep.
So we heard from Professor Stephanopoulos over lunch that in order to do effective controls, like in the early days, I guess, it's helped to start with good physical models. So you have the equations of fluid mechanics and reactions, and you do your optimization based on that knowledge. When it comes to reliability, it seems like your approach is purely just looking at the data, looking for trends. It seems like a much harder problem, but is there an opportunity to also develop the science of reliability in specific areas, like like corrosion or mechanical failure, that sort of thing? So you're not just mining through data, but you actually are also leveraging the science and understanding that better.
Oh, absolutely, and the fact is that a lot of what's behind some of the analytics is the science of chemical engineering. Corrosion is an analytics, is really a reliability problem. So how are you able to predict corrosion to that can be easily predicted, by the way.
Probably more valuable.
In some countries, and I can tell you of one for sure that I'm from. But absolutely, but also it's not only analytics on the data. What we're also thinking, and our customers are thinking, is how do you leverage all that analysis back into our optimization technologies? So if you're able to create, look through the data and see patterns in the relationships between variables, can that be the seed model for a multivariable controller? Or can that, if you're able to predict flooding, how can that be a feed-forward variable also for your control technology? So there's a lot of aspects, and it really opens up a whole new area of value creation as you start developing analytic solutions. Yeah. Thank you. Yeah.
Yeah, so actually it was very impressive.
Thank you.
When you're dealing with with petrochemical plants, there's a lot of fixed equipment in there. And yeah, I did have someone who taught here in a control system, so I have an understanding. And do your models take into account the variability of the raw materials that enter into that plant? That's a very big issue of what's the quality, what's in it.
Yeah.
It can vary drastically.
Okay. Great. So that's a great question, because today Aspen Technology has about 6,500 multivariable controllers on process units around the world. you develop the models that that controller will use to control that process unit. And the minute it's implemented and online, the process conditions start changing because they started to process a new type of crude, or the catalyst is degrading, and therefore the reaction is not the same. So the Achilles heel of multivariable control, we learned, was the process conditions beginning to deviate from the ones used for the model, or the engineers that were there to maintain the controllers move on and they're no longer there. So when we talk about automation of knowledge work, what we've done is we've automated the adaptation of those models to the process conditions, where now the controllers, where they're online, they are looking at the process conditions and adapting to the new process conditions. So the models are being automatically adapted online. So we took the engineer out of the process. And in a way, that's what automation of knowledge work will do. There's a lot of discussion about what artificial intelligence means for employment going forward. But what it really, in my opinion, what it really does is elevate then the people to the next level of service that has to be provided. But that's how we address that problem specifically. And we introduced that technology about 5 years ago now, and it's one of our best sellers now, because refiners and chemical producers have realized that the way to solve the problem is to have adaptive process control, tuning the model to the process conditions as the process conditions change. Yeah.
Students have questions as well. Oh, yes.
We do have job openings in AspenTech.
Antonio, thank you very much for a very inspiring talk.
Thank you.
I have one question that is related to our educational mission.
Mm-hmm.
What sort of new skills would you like your next high-risk chemical engineers from this department to have in order to support your efforts to achieve this vision?
Well, let me say the following. So I graduated actually 30 years ago, now that I think about it, right now, 1987. We hired a lot of recently graduated engineers from universities, including some from MIT. And I'm impressed about the quality of the engineers, especially presentation skills, the ability to put thoughts together and communicate your ideas. If I think back, I don't think I was ever as good as you guys are today coming out of school. If I think back in my career, while I had Fortran 77 training, if you know what that is, it was very incipient, and I had to be trained on how to do programming when I joined SetPoint. But I find that chemical engineers today come out with very good programming skills as well. So if I think about it, all those boxes are ticked. It's what I talked about today, George. I think we're at the beginning of a technology revolution, in my opinion. The last 20, 30 years on technology have only been about laying the foundation for what's going to happen over the next 20, 30 years with technology. And I think that's going to mean that chemical engineers are going to have to, at some point you were required to know how to program. You're going to be required how to do some data science as well, some analytics, and a broader set of skills that perhaps we're not even familiar with today. But at least that's what I think it will be.
If I may follow up with, I joined this department in '84, and at that point, I view the computer as a very efficient, very fast number cruncher. And here at MIT, it was the revolution of the second phase of artificial intelligence. It was raving all over the place, and I fell in love with it. But I recognized that computers were not the number crunchers, I thought. They were information processing, and they process informations with the elementary digits of 0 and 1, but in very, very different models. you try to capture the knowledge, the expert knowledge of a human in terms of expert rules.
Yeah.
You have a predicate calculus for logic, etc., etc. And my question, for example, is how can we get the crystallozua, that's how I call the early computers with, some intelligence, like the protozoa, into extensions of our human intelligence? What sort of education, what sort of preparation in technical matters or in non-technical matters, mindset type of a matter?
Yeah. Well,
So the computer is an extension
absolutely.
of a person rather than
Yeah.
a tool that crunches numbers very fast.
Yeah. Well, we were talking about this during lunch. The thing about today's world is that the amounts of information, the amount of the complexity of the problems, what we can do today is only enabled by technology, by the cloud. The cloud is a tremendous enabler to solve very complex problems because very few companies could put together the amount of computing capacity to solve some of the very complex problems that exist. But now with the cloud, anyone can go rent a space on the cloud and pull together a huge set of high-performance computing assets to solve very complex problems. What that really says is that the complexity of problems that we're going to be solving is going to outpace our ability to really think about them. And this is where then I think about artificial intelligence and perhaps neural networks, in that we have customers that with our planning solutions, they were able, in the past, they were able to do 2 or 3 scenarios about what crude oils to purchase, and they had the time to make that decision because it was 2 or 3 options. We have customers that with the cloud, they now want to run 1,000 scenarios. They want to do it 24/7, and that's feasible. That can be done with the cloud and high-performance computing. But then who's got the ability to interpret and the time to go through 1,000 scenarios to determine which is the best of those scenarios? This is where I think artificial intelligence is going to come into play, cognitive learning, so that while we go after big problems with more computing capacity, more technology, the ability to interpret the results is going to have to be an extension of the human in order to process through so much optionality in a timely fashion to be able to use that information. That's how I think about artificial intelligence. I'm not there yet that artificial intelligence is going to take over the world, but it's a long time between now and the end of eternity, so you never know what's going to happen here. Yeah. I hope I answered your question, George.
Thank you. A lot of the work that you've described your company is doing seems very closely related to classical operations research. The problems we've studied as, linear programming, network flow, min-cost flow, the knapsack problem, job shop scheduling, mixed integer, all of that. But recently, it seems that most of the optimization I hear about being used is something that's not applied to a model, but rather a sub-problem of the machine learning process, namely these convex optimization problems that are a piece of the whole machine learning cycle. So I'd like to ask, what is your opinion of the future of classical operations research, classical optimization in the world that you see?
Yeah. Well, I'll try to distill it to a simple answer. So as a CEO of AspenTech, when you become the CEO of a company that has already been in the market for 32 years at the time, the question that you ask yourself, at what time do we run out of runway? At what time do I run out of luck because some disruptive technology shows up and completely changes the business model? In thinking about that, I truly believe that machine learning, analytics, artificial intelligence could be the type of disruptive technology to the classical modeling of operations. Not the design of those assets, but once those assets are in operation, if you can model those assets through machine learning or pattern and search recognition, then of what value are the models? And perhaps you can do an even better job because you're actually deriving empirical models from the actual process data. You're not predicting something at that point. You're deriving models from actual process data. Our approach has been to embrace these technologies and embed them into our solutions to enhance our historical products going forward. But I do think that the potential is there to disaggregate either your traditional modeling, advanced process control as well, from the supply chain of technologies where machine learning and analytics start taking on some of the characteristics of these older technologies. I hope I answered your question. Thank you.
Just a quick question about that, the business part, and I want to know that if how is your company connected to the others company? It means that like as the SAP or OSR software or all of these companies try to do that the same things, and do you have any options for them to help them, or no, you want to be completely separate from them?
Well, I mean, look, certainly these companies you talked about are competitors of AspenTech. I think that the first thing I'll say is there are some companies out there that are positioning themselves as a platform for any type of capital-intensive industry from an analytics standpoint. The problem that I see with that positioning is that there's no value in being a platform. There's no value in data capture. There's no value in visualization. The value is in the applications that make something out of that data, give it context, and then prescribe a solution. So to us, we'll have to integrate, because OSIsoft captures a lot of the data as well if it is in our product. We'll have to integrate to them. But we also think that companies like OSIsoft run the risk of being disaggregated from the supply chain, because when you're trying to capture so much data, they may end up in Hadoop, for example, where you do then all the real-time data management, all the transactional data processing at much faster speeds than any real-time database could do it. So to me, over the next 5-10 years, there will be a lot of movement in the technology picture as far as winners and losers. And I think eventually companies that win are companies that create value for customers. Being a data repository going forward, I don't think is the answer to analytics and machine learning going forward. Hopefully I answered your question.
And just about the machine learning you talk about, do you have internal machine learning algorithms, or no, we can use that, for example, Azure has the same system too, and you can implement that, you bring that your databases and do that the calculation in the Azure too. Can we do that with the same things in the Azure or no?
Yeah, we can move our solutions into the cloud, whether it's Azure or Amazon Web Services.
All right.
Well, we have reached our 4:30 time, and I'd like to thank our audience and thank our speaker,
Thank you.
Antonio Pietri.
It's a great honor.
So much.
Thank you.